Okay, there's a lot going on this particular page, so let's just talk through it real quick. Injective, surjective, and then invertible. So you have three things that you're trying to check for each of these functions. So first things first, the injective bit is probably the easiest to deal with, so in this case, in this first one, basically all you need to do is find two. So f of 0, 0 is the same as f of, let's see, f of 0, 0, let me write it here, is going to equal 2 to the 0 is 1, 1 plus 0 is 1. And then f of, let's see if we can make another, how about we'll do negative 1/2 and 1/2. There, that'll do it. That also equals 1, because 2 to the negative first power plus 1/2 is 1. Anyway, so this means that this is not injective. This is surjective, because no matter what number in the reals you want to find, you just let, so f of x equals, f of, let's see, what can we do here? 0 and use x minus 1. So there's your formula. Plug 0 and x minus 1 into this, and you'll get whatever x. So this will hit every single value of the real numbers. So this is surjective. And if it's not injective, it can't be invertible. So not invertible. The next one, so this one's pretty easy to show. Just let's just make a little table just to illustrate. F of n. Let's see, we're going from the reals to the reals, so negative 3, negative 2, negative 1, 0, 1, 2, 3. And of course this goes on infinitely in both directions, but this will just illustrate what's going on here. We're doing the floor function of n over 3. So this will go down to negative 1. Negative 2/3 gets rounded down to negative 1. Negative 1/3, and then 0 becomes 0. This is 0, 0, 1, and so on, dot, dot, dot. So hopefully you can see here that you get these things in triples. This thing is not injective because you have not injective. But it is surjective, it's covering everything, and of course because it's not injective, it can't be invertible. Okay, this next one, here again I think it might be helpful to draw a table. So this becomes 4, 2, 0, 2, 1 and 4. And that goes on, of course. You can see clearly this is not injective. This is also not surjective, so this is neither injective nor surjective. And then this is not invertible. Final one. And this is one that we had, I think we had it on the practice test, so I don't know that I need to go over this, but I guess we could just do it real quick. Let's see. Let's see. It was something similar. I don't think I had this one. Let's see if this one works. So let's do n, and here we're dealing with just the natural numbers. 1, 2, 3, 4, 5, and then we'll do negative 1 to the n times the ceiling of n over 2. Okay, so n over 2, 0 over 2 is 0, so this is going to be 0. 1 over 2 is 1/2, the ceiling is 1, and that's going to be negative 1. This will be positive 1, this will be negative 2, because the ceiling of 3/2 is 2, but then you multiply by negative 1, 2, negative 3, and 3. So hopefully you see how this is working. This thing is injective. There aren't going to be any repeats here. You could actually prove this, but we don't have to. This is surjective as well. And because it's both injective and surjective, it is invertible. The inverse, yeah, it'd be kind of hard to nail down, but I'm sure that we could come up with a formula. It'd probably be a piecewise formula.